Welcome back. In this lesson we're going to look at solving quadratics using a factorization approach and the Null Factor Law. So let's jump in. To start off the lesson, a bit of an activity for you and a partner or you and a team, and we're asking the question, does factorization beat trial and error? So firstly, I recommend you do this in your established teams, and you can split your teams in half perhaps and compete against each other. Like this is just an activity, it's not a proper competition. Or if you wanted to, you can set up with another team so that your entire team is racing against them. One of your teams needs to be the trial and error team. So that's up to you to decide who is who. The other team will be the factorization. Don't start until you're ready, but the idea is you need to find the two solutions to this equation. The 3x squared minus x minus 2 equals 0. And the team A has to just guess. So you're just guessing values, checking the answer. I don't want you to use any factorization. Be really conscious about if you already know ways to solve this, I want you to guess. It has to be sort of guess-based, which is this trial and error. The other team, I want them to factorize the left-hand side. So using sort of a process that we've seen before, try and factorize this out. And I want you to see who comes to the solution first, who is actually faster. Discuss the process you used between your two teams. So now when we're looking at solving quadratic equations, there's a key term that sort of pops up now. And we talked about solutions. Another common term that we use for these, for quadratics, is called the roots. The roots or the solutions, they're the same thing, but often we talk about roots when we're talking about the function, and solutions more so when we talk about an equation. So what are they? The roots or the solutions to a quadratic equation are the values that x can have which satisfies the equation or makes it true. So very similar to what we saw in linear equations. We said, what are the solutions to it? It's saying, what values make it true, make it work. So similar to, again, in linear equations, we kind of said, is a point on a line? If you plug in that point and you get something that's just garbage, like 4 equals 2, you know that that's not a solution. It doesn't make sense. It's not on the line. It's very, very similar in quadratics. The solution needs to satisfy the equation. So let's take a look. Here we've got x squared minus 3x plus 2. In this case, we're saying when x equals 2, and we've subbed that in, we get x squared minus 3x plus 2 becomes 2 squared minus 3 times 2 plus 2, which we condense 4 minus 6 plus 2 is 0. But that's good, because we originally said that this equation has to equal 0. So we're basically saying, what value can x have so that this whole thing cancels out to give you 0? And in this case, it's 2. There are sometimes more than one solution or one root to a quadratic. In this case, x minus 2 is the solution, but in many other examples, we'll see there can be 2 solutions. Sometimes there can be no solutions, and we'll talk about what that actually means. What is the significance of a function having no solutions, 1 solution, or 2 solutions? But that's a bit later. That's when we talk about functions. For now, we're just talking about quadratic equations. So the key point here is that the roots of an equation are the value, the x value, that make it true. So the first method we're going to look at for solving a quadratic equation is called the Null Factor Law. And I love this law. This is great. What it's saying is if you have two numbers, so A times B, if that equals 0, there's only two options. Either A is 0 or B is 0. I mean, potentially they could both be 0, but that's an arbitrary solution. It's not really any useful to say, well, cool, they're both 0. That's kind of useless. It doesn't help us solve anything. But because of the way multiplication works, anything times 0 is 0, straight away when we have something times something equals 0, means that either this equals 0, oops, I wrote B, or this equals 0. So that is the Null Factor Law. As it's sort of highlighted in our little green box over here, we can see if AB equals 0, then A equals 0, or B equals 0. So that's one method we can use. We've talked about completing the square. The quadratic formula we will use later, And technology we'll use later as well. That's things like GeoGebra and graphics calculators. They can do a lot of this for you. But sometimes we'll be required to do it by hand, such as this course. So we need to know these tools. So let's have a look at a worked example. So let's start with A. We've got 3x squared plus 5x equals 0. Let's see how they've done it. So what have they done? They've pulled out an x. So we said there is a common factor here. So this is the first step. The common factor is x. 3 and 5 don't have a common factor. So you pull out x, you're left with 3x plus 5. And you double check, x times 3x is 3x squared, x times 5 is 5x, great. But now we've got the null factor because we've got this times this. This is our A, this is our B. A times B equals 0. Therefore, either x equals 0, such as the A, or if this is not 0, 3x plus 5 has to equal 0. So if 3x plus 5 equals 0, we do some rearranging. You're going to get minus 5 on that side. You divide it by 3. You're going to have x equals minus 5 on 3. Or we could just say, so we could just say that. We could just say this equals 0. I would rather see you expand it out to get the minus 5 on 3 part, to actually sort of rearrange, practice that rearranging, get your answer. So here's our solutions. Either A equals 0, which is just nice and easy, x equals 0, or if B equals 0, x has to equal minus 5 on 3. And you can try it. Chuck minus 5 on 3 back into this equation and see what happens. And you're going to get 0, which equals the right-hand side. That's what we expected. In this example, we're doing the same thing, except what have we got? We had an x squared equals 5x plus 6. They've moved it across because we need it to equal to 0. If it doesn't equal 0, then we don't know if it's a root or a solution. So we just rearrange. We get back to our quadratic. So they're just trying to trick you in that first line. And then here, they've expanded. So they've used that factorization process. We're going, what two numbers multiply to give minus 6 and add to give minus 5? So it's a minus and a plus. In terms of the order, sometimes that's a bit of trial and error. Just check if you do it the right way around. Plus 6x minus 1 is plus 5. So that doesn't work. So we have to do it the other way around. But then once we get to this step, we've got our A and our B. So either A equals 0, which means x equals 6, or B equals 0, which means x equals minus 1. So there are solutions, our roots to the quadratic equation. Two more examples here using similar processes. In this case, these are non-monic quadratics. So we're really expanding on what we saw before. This is why we did the monic and non-monic factorization first, because it's crucial here to be able to use these tools to get it to a null factor law. One thing I'll point out though, in this case, because you've got 2x minus 1 all squared, there's only one solution because A and B are the same thing. It's basically A times A. So all we care about is if 2x minus 1 equals 0, that gives you the half. In this example, we had different values, so we had two solutions. Some more step-by-step worked examples if you want to have a look. So these are monics. Part C is non-monic, but there is no x term in that. In B and C, there's no x value. There's only the x squared values. Again, here we're starting with monic, and then C is a non-monic, if you want some more worked examples to look at. Now let's do some practice. So for these ones, let's have a go at, in fact, let's do the first and last columns. And for this one, we're now looking at a variety of them. Let's do the middle column. That looks pretty good to me. Again, solutions on the right-hand side here. These are sort of the step-by-step, so a little bit lower resolution than I'd like, but it does give you every step, so you can check your working. Some more practicey questions. If you're feeling pretty confident, because some of these are very similar to what we just did, again, maybe just try. Generally, they increase in complexity. So if, for example, I'm going to say, have a go at these ones here. If you're like, this looks kind of similar to what I've done, just try maybe the bottom one. because generally that's the harder question. There are different types of ways that they'll do it within these questions, but I would generally say the bottom one is going to be the harder one. So if you're fairly confident, try the bottom one. If you get it wrong, you have to do all of them. That's the rule. Okay, so again, we're solving. Let's just do first columns. Solving. Yep, first column. And in this case, with the last column, because that looks like there's some good challenging questions in there. So first, last columns. In this case, we're taking out a common factor first. So it's really not that different. We're just taking out a common factor. So let's throw that in there. First, writing out in the form. So they want us to expand and rearrange into this form. So again, we're just adding a small step. Nothing crazy. Let's do that. And then now, first writing again, we're rearranging. So we have to move some stuff around. Times it by x, move stuff across. I think that's relatively basic. It just involves a lot more algebra rearranging. So let's just do those three for that. If you want a bit more of a challenge, these are some of the challenge problems out of the textbook. First, multiplying by an appropriate expression. So in this case, rather than pulling out a factor or expanding, they're saying figure out what we need to multiply both sides by in order to get an equation that we can then solve. So for these, this is challenging, so I'm going to leave this as an optional task. So if you want a challenge, you can, but this is a little bit of an extension from what I'm sort of expecting most people to be able to do. So feel free to have a look at this. And again, if you want to do that, maybe just do like every second one. Do like, I don't know, AC, so these two columns. If you want to have a go at that and see how you go. So that concludes this lesson on solving quadratics and the null factor law. We'll pick it up next time.